brief little introduction about Sajal ji. He is an alumnus of IIT Delhi, more than 32 years of industrial experience with major focus on R&D, technology, applications development, indigenization, and innovation management in the field of specialty engineering, plastics, composites, resins, and glass fiber reinforcements. He has presented and published many papers, delivered keynote addresses, and chaired the sessions at national and international forums. He has made a significant contributions in Tata's global Innovista program, an external assessor of Tata Business Excellence Model. Sajalji has also worked with CIAT Limited, Glass Fiber Division, FGP Limited, Tata Chemicals, Specialty Engineering Polymers Division, and Tata Autocom Systems Composite Division, as you said. So with having this mastery on the subject, sir, we are looking forward to get some knowledge on the subject from you. Over to you, sir.
Thank you very much. Really, I am very much excited with this opportunity. See, Mr. Pathak, whom I call Pathak sir, okay, we are known to each other for a long time. So before he was one of the decision makers Tata Autocom Limited, I was connected with him through our Tata Business Excellence model. Yes, so over the last so many years, we have shared a lot of interaction with each other. And then 31st January 2024 was my superannuation from this Tata Autocom system. 2 days earlier, when he called me and spoke about this thing, I told him, yes, sir, I will be very busy for these things. Then it will no issue. You just give an introduction to start with, and later we can speak details about the subject. So it's a very short notice, and as such, I am not able to complete the entire presentation. And in my personal laptop from my company presentation, all those things. So some slides still will show Tata Autocom System Limited, but these are basically for understanding. So I request not to copy this thing, but in case you need some information, I shall be able to share with you as and when it is required. You can let me know. Okay. So what I will do, I have a few slides which prepare today as a topic just to outline what I shall speak today. I feel those who are online today for this interactive discussion, all of you might have ideas about the composite or may not have, but majorly what we find and during my professional career as well interaction with the people that the basics gets missed most of the time. So I will touch upon the basic things today, and maybe later we can have a series of talk on the subject for having a better understanding. Okay. So what I will do, I will share some. Are you able to see it?
Yes, sir. Yes, sir.
Okay. See, this one slide I would like to speak. Okay. So first thing, what are the composites? Composites actually combination of minimum two or more than two different type of elements coming together to give a new material. Performance of which material are completely different from the constituents. So combination of two or more materials to form a different materials whose performances are different from the constituents elements. So in material A and B, say two material A and B, they combine, just not a physical combination as such. It may be a physical but different type of physical combination. So mostly there is a chemical type of interaction among the constituents, particularly the matrix and the reinforcement through interface formation. So A and B two material, A might have some performances on its own, B might have some performances on its own, but when they combine together and form a material C, then the performances of C are different from the performances of A and B. There are particularly two materials very important. One is the binder phase or matrix phase. Another is called the reinforcing phase. So if I take two materials, say generally this binder material which we call matrix, which actually forms an interface with the reinforcing fiber. Fiber may be glass, carbon, aramid, natural fiber, whatever the kind may be. Then the material which binds the reinforcement, that is called matrix or binder. It actually receives the stress, and the reinforcing fiber which are in a higher performance in terms of strength and stiffness generally, they actually carry the load. And this binder material may be polymer, may be metal, may be ceramic. So depending on the matrix material, composites are three types: polymeric composites, metallic composites, and ceramic composites. Ceramics matrix composite, metallic matrix composite, and polymer matrix composites, or plastic matrix composites. Today, we shall predominantly talk about this polymer matrix composites. Material we use for composite we generally call is resin material, either thermoset or thermoplastic. So, what are the performance of the resin material we should look for when we are designing a composite material? So, type of resin will definitely will make an important parameter. Type of material, what type of strength, stiffness, and other performances you are looking for, whether structural or semi-structural. If it is a commodity polymer, your performance will be something. If it is an engineering polymer, your performance requirement and will be different. If it is unsaturated polyester resin for general purpose application, there are so many million types of unsaturated polyester resin for general purpose, for special purpose, for structural, semi-structural, all those type of things. Isoresin, orthoresin, vinyl ester resin, malic resin, all those things. Whether you are looking for chemical resistance, whether you are looking for just a general purpose application, whether you are looking for a class A type of application for the vehicular application, or whether you are looking for in a high toughness, or whether you are looking for high stiffness, is depend on that. Viscosity plays a very important role, all because when we are forming a composite material, so weighting of the fibrous material or fillers material with resin is very, very important. So, and then it should have a good interface. Otherwise, composite will not be performing material for that application. Molecular weight is important because as the molecular weight increases, your performance of the material increases, and after certain molecular weight, it's get asymptotic. Okay, and then molecular weight distribution. Molecular weight, there is not a single molecular weight for polymer, or for obvious reason, because there are random chains of different chain length. So all the polymeric chain will not have the same molecular weight. So there is a number average molecular weight, there is a weight average molecular weight, also viscosity average molecular weight, and weight average molecular weight by number average molecular weight. That is called the molecular weight distribution or polydispersity. That is very much important for performance. Branching or straight chain, this also become very important, because if there is a branching, then material may not be high molecular, but even it will be viscosity, high viscosity. We generally call that viscosity more mean higher molecular weight, but where branching is there, it may not be there. So if it is branching, the processing will not be good, and even for low molecular weight polymer with branching, viscosity may be higher, where the weighting of the glass fiber by resinous material will not be good, and the composite will not perform. Adhesive power is very important for resinous material for getting the proper compressive strength, proper interlaminar shear strength, and proper flexure strength. Whether is composite is performing or not, flexure strength, which we also call the cross breaking strength, that is the measurement. Okay. Then stiffness is very important, particularly where you are looking for the class A type of application for automotive and other application, and some appliances where the attractive look, exterior look is very, very important. Toughness is very important because that it does not get cracked, that does not get cracked on falling, or something is falling on it. And if the toughness is not good, then in that case, if you use it for manufacturing automotive type of composite, then crash, all those things will be an issue. But at the same time, when we are looking for a class type of application, then stiffness of the resinous material is important. But automotive application, your look is also important and crash is also important. So we need to have a balance while formulating the material for automotive type of application. So we talk a lot about composite this, composite that, it can be used here, it can be used there, it is the future, it is the that. But many cases we find the basic understanding of the key performance of the ingredients missing. So when and so they face problem when they are going to design and develop a material for a particular type of end user application. Basalt, all those things, their diameter very important. Filament diameter, glass fiber, what we talk about, the glass fiber, we cannot see filament, a single filament, we cannot see with our naked eye. One human hair in 100th time thicker than a glass fiber filament, and it's 7 micron to 17 micron, 7 depending on the what type of application we use. And when weighting is there, weighting the fiber means fiber surface with resin, we are basically weighting the surface of the fiber. So when the filament diameter is less, so for a particular for a quantity of fiber, you have the more surface area to cover with resin, so you may require more resin, but at the same time you will get much higher performance. Takes basically one mass of the fiber in gram or kilogram per 1 kilometer of fiber. 1,000-meter fiber weight in gram, that is basically the fiber. Text is important because we use most of the cases glass fiber not as a filament. In all cases, not as a filament, we use as a strand. So that strand text is very, very important. Sizing, glass fiber is an inorganic material. It is the mix of inorganic oxides, nearly 50 to 55% silicon oxide. So it is an inorganic material. We need to get it compatible with the organic material, but a single type of, different type of, some aliphatic, some aromatic, some thermoset, some thermoplastic, some polar, some non-polar, all those things are there. So what we need, we cannot, if we use the glass fiber or with resin without any treatment, which is called the sizing, then and there will not be bonding, there will not be the interface. Okay, I will tell you one thing, the composite how the composite to understand in a simpler term. I will tell after some time. So this sizing, actually the material which is used for compatibility with different polymers. So for compatibility with different polymers, sizing is also different. And sizing is the major technology in glass fiber. Sizing will either make or break the composites, and this is a very, very proprietary. Okay, sizing cannot be done by each and everybody. Okay, it's a very, very specialized. So when we are drawing the glass fiber in that diameter and with enormous speed, actually, and it's get melted at 1700, 1650 to 1700 degrees centigrade. Then it's get filtered. Then it get fiber drawing happen at nearly 1150 to 1200 degrees centigrade temperature through platinum, gold, iridium, metals, bushing. Bushing may have 2400 to 4800 and small hole of that diameter, and the temperature is like that, and immediately below that temperature, it is generally AC room. Fiber drawing is AC room. It gets coated with, see that temperature, and then when it is coming out of the bushing, temperature is room temperature maintained at 22 degrees centigrade temperature, and when and is comes out, if we don't coat it, it will be like a needle. So it's get coated with a sizing formulation, and then it's get wrap around a bobbin at very high speed, and then and drying and post processing, all those happen. So like each lock is having a specific key to open it. You cannot unlock a key with any lock with any key. There is specific key for a specific lock. Similarly, for a specific polymer matrix, if it is polypropylene, if it is ABS, if it is polycarbonate, or if it is polyphenol sulfone, or if it is unsaturated epoxy or bismillamide, whatever the cases may be, for each type there is a special type of sizing. So if you miss it, just like you are trying to unlock a key with a different lock with a different key. No. So this very important. One of my bosses used to tell me, "Are Sajal, glass fiber is glass fiber. So why that this compatible, that compatible, this that how it's come? It's like that." And then wetting power of the filament is important, and this depends on what type of. Before that, I would like to add that sizing type, that strand integrity. Sizing is a formulation. It contains maybe a dozen of different type of chemical, half dozen of different type of chemical, water based generally, so that there is no harmful VOC, all those things. So one is primary film former, which coat the glass fiber. Then with secondary film former, which reinforces it. Then there are lubricants used in the things, so that when you are processing the glass fiber, whether during winding, during assembling, during weaving, during chopping, all those things, and during transportation, that it does not one strand maybe 75 to 250 filament together, that they don't get separates out. Metal powder in nano form, all those things. So all those things have become very important for composite industry. See, this will be, I have already explained why, composites are subjected to mechanical loadings, and nowadays electricals and electronics loading. Okay. So tensile, if we get a composite material with good tensile, so what are the things that we should look for? So type of load response is dependent mainly on this tensile stiffness and strength properties of the reinforcement become predominant for this purpose. Because our major purpose of using reinforcing fiber in plastic materials is to increase its strength and stiffness. Okay? And since these are the far higher than the resin system on its own, I will give an example. If you take a typical SMC material, if typical resin material, so tensile strength is generally 3 GPa. Yes, tensile modulus is 3 GPa. Whereas the tensile strength of e-glass filament is 72 GPa. And tensile strength is 50 to 60 MPa, whereas the tensile strength of glass fiber is many times higher than this. So, in a composite combination, fiber plays the dominant role of determining the strength and stiffness of the composite material. So, if we are looking for a application where tensile performance will be the predominant one, we should look for proper reinforcing. And sizing plays very crucial part. As such, glass fiber manufacturers, they test their fiber whether it is the really good compatible fiber for a particular resin. They measure this cross breaking strength. For unsaturated polyester resin, it is generally 205 MPa. Okay, if they get that thing, they say yes, the sizing material they have used for this particular glass fiber grade is good, correct, and their supplier has also given them the correct material. Okay, so these are basically very to get the desired performance in terms of tensile, flexure, shear, compressive, all those things. So understanding of the raw material in the true sense of the terms for formulating a particular composite material are crucial. And I have the hands-on experience on these things because I have worked with the glass fiber manufacturing industry. I have worked the plastic material manufacturing industry, and at the end, I have worked with the composite division of Tata Autocom System Limited, where I am the person responsible for the different design and development of different types of composite material for different types of applications. It is like this: for headache medicine is something, for diarrhea medicine is something, for fever medicine is something, okay, for coughing material is something, for headache material is something. So single material is not the remedy for all the diseases. Similarly, a single formulation is not the remedy for all type of application. That is why understanding all those ingredients in their true sense for deriving in a proper composite material for the perfect meeting the requirements of an end use applications are very not only important, are very crucial for the growth of the composite industry as a whole. Otherwise, we will have people only depending everything on the what supplier is telling to sell their material. Okay, thanks a lot for your patience.
Tell us some simple examples, where what is the major reason for using a composite? One I can understand is straight away weight reduction. In an automobile, you want the steel to be replaced by fiber because it will have lower weight, the same strength but lower weight. And then you also said about conductivity. You want item which is insulating and not conducting. So insulating, you make a what you call composite, which is insulating in case
Sir,
of electronics, etc. But
sir,
what else? What else
yeah,
could be the reason for
yeah,
composite?
yeah, 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 yeah. Sir, specific strength and specific stiffness. That is basically strength and stiffness by specific gravity. That is much higher for composite than steel. All those corrosion is a very big factor, no sir.
Yeah, yeah,
Then
corrosion,
denting
yes.
and dent resistance. Composites is having a very good dent resistance. So that is why we can export even the painted parts. You cannot do this with the steel, all those things. Denting are very important. Plus, number of tools requirement for or composite is very less. So tooling cost is nearly 35 to 45% lower. And you require less number. You can have a lot of integration of the parts. So for steel, when you require maybe a dozen of tools, but half dozen of tools, here you require only a single tool. front end and front panel of S. They had 6 7 tools, but with tools and the time. So manufacturing time is also much higher, and to bring the product in the market is much lesser in composite. And so there are a lot of design and freedom for composite. That design freedom you cannot get for composite, for metal. So there are so many things. And not only that, if you see the sustainability aspect, NVH performance, you cannot think of without composites.
Sir, we have a specific application now, sir. We are making a remotely operated vehicle. The vehicle has to move in a high magnetic flux area. In smelter, if you see, they are applying around 25,000 amps between electrodes. So, and there are a lot of smelters in a given place. So the flux is more than 200 to 300 gas. It is in between 200 to 300 gas. So our electronics and the other electrical systems are, very hard to operate in that area. Do we have some composites, or how do we go about making a composites to insulate our control systems, sir?
Insulate the system, insulation. It will work as an insulation. Am I right?
Yes, sir. Regular insulations are allowing the magnetic things to pass through. We need a flex, magnetic flex repulsion or something, protection.
Okay. So, particular, what are the performance of the material you are looking for? Just can you please elaborate a bit?
See, we are operating a typical drive system, around 3 to 5 kilowatt systems with so many controls for actuators and all. Nearest to that, our rover, the remotely operated vehicle, is a smelter part which is using a current to the level of 15 to 30,000 amps. And there are 12 such electrodes. So the intensity of magnetic flux is very, very high.
I think it was an excellent lecture. I would like to say this composite industry is a very complex design industry, particularly to how to mix all the ingredients to the right mix. But as I see, a major challenge is in the production side of it. I would like some advice on what are the type of manufacturers available in the composite industry who can make a product on a mass scale. Beyond prototypes. The design itself is very complex, as very well explained today. But the actual manufacturing and how to mix the ingredients in the right quantity, right quality, right from the resin to the glass fiber and all this.
Sir,
the type of machines that are needed and how to go about it, because this is an industry which is bound to grow.
Those are operated mainly by the SMEs. Okay, and they don't neither have proper understanding nor the proper infrastructure to do it. Rather, to meet the cost, all those things, they do something else. Okay, so it becomes very difficult. But yes, nowadays you can get the quality manufacturers. Even you can contact. I can give you contact and get contract established with them. You can work with them absolutely no issue. But one thing, for mass production, see, I come from the automotive industry background. I have worked in glass fiber industry, polymer industry, and finally composite industry. What we have at TACO, that those are mainly, the next slide was I was going to tell. Here there are processes where mass manufacturing happen. There are processes where you cannot make mass manufacturing, but and your requirements are also not very high. And in that case, people go to different SMEs. SMEs there, the things are not is controlled, and it is not properly made, and composite gets the bad name.
Very correct.
But composite is a high potential material. If we properly, I always say, what is the constant for composite? Constant of imagination is if you can imagine something, you can make it in composite, because there are so many processes whereby you can you can mold the part, unlike others. So imagination, constant in imagination is the major constant in composite industry.